Okay, so this is a continuation of partial pressure using Pivnert. So number 4, a certain container contains 3 moles of hydrogen gas and 2 moles of oxygen gas. The total pressure in the container is 100 kilopascals. What is the partial pressure of hydrogen and of oxygen in the container? Well, using Dalton's law, which is the total pressure equals the pressure of gas A plus the pressure of gas B, you can set up an equation with a variable x, which you can solve for to find what P is. So P of total, pressure of the total equals pressure of the hydrogen plus the pressure of the oxygen. You know that there are 3 moles of hydrogen gas and 2 moles of oxygen gas, so the total pressure equals 3x plus 2x, and the total pressure is 100 kilopascals. So 100 kilopascals equals 5x, and x equals 20. So the pressure of the hydrogen equals 3 times 20, since there are 3 moles of hydrogen. So the pressure of the hydrogen is 60 kilopascals, and since you know that there are 2 moles of oxygen, you can do 2 moles times 20 kilopascals, which is 40 kilopascals of oxygen. So the partial pressure of the hydrogen gas is 60 kilopascals, and the partial pressure of the oxygen gas is 40 kilopascals. Number 5. Oxygen was collected over water at 25 degrees Celsius and 97 kilopascals by decomposing sodium chlorate. 2 NaClO3 goes to 2 NaCl plus 3 O2. If 1.48 liters were collected, how many grams of NaCO3 were decomposed? First, you have to solve for the number of moles of O2 that were produced using Pivnert. The temperature is 25 degrees Celsius plus 273, which is 298 Kelvin. R is a constant at 8.31. You have to solve for the pressure of the dry oxygen by subtracting the water vapor. The water vapor at 25 degrees Celsius is 3.2 kilopascals, so the pressure of the oxygen is 97 kilopascals minus 3.2 kilopascals, which is 93.8 kilopascals. So you can rearrange Pivnert in order to solve for n, and then solve in the values that you are given or solve for. So 93.8 over 1.4 or times 1.45 liters over 8.31 times 298 Kelvin equals n. So 0.0549 moles of oxygen were produced. From the balanced reaction, you know that for every 3 moles of oxygen produced, 2 moles of NaClO3 is consumed or decomposes. So 0.0549 moles of O2 over 1 times 2 moles of NaClO3 divided by 3 moles of O2 in order to convert from moles of O2 to moles of NaClO3, and you get 0.0366 moles of NaClO3 consumed. Now you just have to convert moles into grams. The molar mass of NaClO3 is 22.99 from Na plus 35.45 times Cl plus 16 times 3, because there are 3 oxygens, which is 106.44 grams per mole total. So 0.0366 moles of NaClO3 times 106.44 grams per mole, which converts to grams by canceling out moles, is 3.99 grams of NaClO3 decomposed. So I hope you learned something from this, and good luck with partial pressure.